So I guess this is the first of the community project kind of talks. And I'm going to go through some experiences I've had, and if hopefully you get something out of it, and if not, I guess you probably should have gone to the Apple talk next door. So I'm co-founder of Vermonster. It's a design and dev shop here in Boston. So I'm like super excited that this event's here. This is like a hometown for me, and I'm glad to see it happen here. There's a lot of health IT stuff going on in the area. I've been developing software apps for 15 plus years, and in kind of health IT space for the last 8 years. And I'm a co-organizer of the local, we have a local FHIR meetup here in Boston, and I help run that. If it hadn't been for FHIR coming along, I probably would have migrated out of health IT. So I'm a big fan of FHIR and really feel that it's an enabling technology that makes it possible for developers who follow contemporary practices to participate in health IT application development. And so I'm going to try and take a quick 20 minutes to talk about my experiences that I've had building smart and CDS hooks apps, talk about some of the architectural challenges and modeling concepts, and I'm going to draw analogies I found. Eva at the beginning talked a lot about patterns, and I like patterns, and I found that the way that some of the apps that we built kind of followed a lot of responsive web design patterns that kind of came up back 5-10 years ago. And I have a little node library. None of the talks have live coding, so maybe that's a sign. But maybe I will show something at the end. We'll see how it goes. So in theory, we are a consulting company, and so one of our clients back 5-6 years ago, 7 years ago, was McKesson, and we convinced them to try to start building apps on FHIR. And the theory was they had a couple of EHRs inside their organization, and we wanted to build applications to respond to the change from episodic care to value-based care, and they had all these EHRs, and they didn't want to build the same thing over and over again. So we said, hey, let's try this new technique. We'll build once and use many times, and it'll be great. Then we found that there's 6 minor versions from DSTU2 on upward, and there's no EHRs out there really that have exhaustive implementations. So in practice, it wasn't so much that we found. So like I had alluded to at the beginning, where have we seen this problem before? Well, this is an old visualization that only goes to 2015, but you can see here, this is evolution of the web, some project that someone did to showcase HTML5 stuff. You can see as time's gone on with web technology, there's been all sorts of stuff that's emerged, and different browsers support different things at different times. So drawing on that analogy, we kind of came with some, early on we came, if you're a web developer, you might have done device detection. Is this Netscape? Is this IE? What version is it? Okay, if it's this, do this. Then, I don't know, people who do web development, this project called Modernizer came in, and you could, instead of doing device detection, you could not care about the device, whether it's an Android app or an Android browser on your phone, or a desktop IE app or a Firefox app. You can use a detection tool like Modernizer to see like what capabilities are available, and I'm going to respond. My app will respond to the capabilities, not to the device itself. And later we had polyfills. So polyfills give us a consistent API so that we can like write our code one way, and then the browsers that don't support it that way, it would kind of shim in or hack in implementations that have that same API, so that as developers we could enjoy kind of writing things once and using the polyfill kind of more on the edge of the system to take care of all the kind of details of making it work across different browsers. So we kind of applied that technique to building our smart apps. So one, kind of the first device detection pattern could be you have a smart app that's kind of specific for one EHR just because of the nuances of that EHR, and that's definitely one of the arrows in the quiver. The other pattern we came up with is testing capabilities. And I'll get into this in a little bit in the next couple of slides. But basically using the responsive web design pattern where you can see, OK, what does this FHIR server provide, and how can my app respond to that? And then the last kind of technique is to either build or use, there's some off-the-shelf normalization services, and that's kind of the polyfill pattern. So capability testing, kind of the non-build it multiple times and use capabilities of your FHIR server to see what you can do. Turns out it's a function of two things: user scope, so like the thing that you do during the OAuth 2 dance, like what you're asking permissions or what the server's giving you permissions to do, and then the server capabilities themselves. And so when you know these two pieces of information, you can, instead of naively trying to write to resources that the server or you don't have permissions to write to, and all that error catching and building your application in kind of a way that catches errors and deals with them, you can proactively do the right things based on what you know about your specifics of your implementation. And so here's like, I hope people know JavaScript, but here's some just random JavaScript from an open source library that we've developed. We're interested in creating kind of high quality NodeJS libraries for the FHIR community and for ourselves, so that we don't have to keep rebuilding them for all of our customers every time we're doing a new project. And this is just a quick thing. The top's kind of boilerplate. Probably the bottom ones are the only things that really matter to this talk, which is being able to ask things like, can I read the patient resource? Do I have the permission to do, or does the server support reading a patient resource? Can I issue a search query for patient gender? And so we like to optimize for developer happiness. We all have to work for a living because society tells us to, so we want to have our work fun. And so we wrote this library to make it a lot easier for developers to write code that's expressive. We kind of come from a background of Ruby, which that's one of the tenets. But in Node, we wanted to write libraries to make that easy. And so kind of a more exhaustive example of that, here's where I'll break into some live coding. So here's the library. It's not quite live coding because I just literally tested this out. So I'll paste this into this, this kind of online running program. So I'm setting up boilerplate stuff. Oh, zoom it? You actually want to read it? I don't think... Well, if you want to read it, I can send you the gist. It's a public gist. But basically, I don't know how to collapse this right side, or else I would. But this top part's boilerplate, but down here you can see, can I read the patient resource? And I'm using this, this open smart health server from the smart project. Can I write? And can I search patient by gender? And so if I simply run that in this little browser tool, I can, in fact, read patient. I cannot write patient, so I could put in my code the ability to, or my application, I can respond in a way that, this is a typo, this should say write. Sorry. See, there's live coding. And then the last thing is, can I search by patient gender? Yes, I can. The server allows me to do that. So, so now you can support multiple FHIR versions. That's awesome, right? You can build your app once and support multiple FHIR versions. Well, that was awesome, except architecture. So the thing we found is that we just assumed that we'd be using FHIR as our domain models in our apps. That totally breaks down the moment you introduce multiple FHIR versions, because now your patient model, if that's also your domain model in your application, is going to be beholden to whatever EHR server you're dealing with, and that puts like all of that into what I like to say the fillet of the system. I'd rather have all that nonsense on the edge of my system. So what we landed on was a pattern where we made domain models that might look very much like FHIR models or standard health record models or whatever, and those would be optimized for developer happiness and building the apps to do the business, to satisfy the business requirements that the app needs to do. And then we have our FHIR resource modeling kind of on the edge of the system. And so kind of in a architecture diagram, if you consider the two kinds of apps, like the kind of confidential apps where you have a client-server piece and the public apps where you don't have that server piece to protect the secret. Incidentally, we mostly do the kind of confidential apps. We haven't really done any production public apps. But the concept's the same, and that you might get FHIRs of some version from the EHR, because you could be talking to more than one EHR. In our case at McKesson, we had 3. The idea is to have some sort of adapter layer, and that's what deals with kind of normalizing that FHIR of whatever version into either a known FHIR version or your domain models themselves. And so if we zoom in on the adapter level, it turns out we had to break it down into 2 pieces because it turns out FHIR has small changes to how you construct a search query, for instance, across FHIR versions. The way you search for patients in DSTU2 for whatever fields might be a little different than you search in STU3 or R4 or whatever. So that had to be encoded in that adapter layer. So how do you do the operations like reading and searching? And then the adapters would have to know how to take whatever kind of FHIR versions and build either my domain models or my one version of FHIR that I'm using internally that might be seen as a domain model. And then for writing, we used a serializer pattern where we basically just had the ability for our domain models to know how to express themselves in the various different versions of FHIR. And we did that with kind of just a serializer pattern. So the adapter kind of has those, the adaption layer had those 2 kind of concepts to them. We also worked with FHIR Profiles, and I was barely getting into HL7 stuff before FHIR, but we did work a little bit with some of the folks from Lantana early on and Fiore, now FHIRly, on understanding how to do FHIR profiling. And it worked out nice when we were in complete control of the ecosystem. So at McKesson, we had the EHR developers on the team that we were able to, as app developers, talk to them, and we would share profiles and implementation guide for specifying how to build the contract. And we could also do it, if you kind of have other direct controls over the HR development team, contractual or whatever. But for most other cases, we really need to be the consumers of profiles and kind of either rely on the EHR, or if you're using an integration engine and they have profiles, instead of defining them. And then our apps, kind of the challenge was to build them to work within the subset of what's supported. For the most case right now, if you can fit in the footprint of US core, the chances of it being adopted are a bit higher than if you're going for exotic extensions of FHIR. The other thing we noticed is that, I don't know if you know this, we run the FHIR meetup, and no one had Windows machine, and there's a lot of people here who are Macs. The IG tools back then, a couple years ago, just barely worked cross-platform, so it was frustrating to use the publishing tools. And we're hoping that and we'd love to help if we could to advance some of that, so that we're not we can hook this up to our CI/CD services and run them cross-platform. The other thing that came up that I think is worth mentioning here, and I'm just going to double check on my time, 14, so I have about 5 minutes left, is localization. So I don't know, I haven't really heard this too much, but a lot of times we found firsthand that when we launch our app, we would want the ways that the observations are spelled. So at McKesson, it was a lot in the oncology space. And so there's a lot of concepts like observations that we would map maybe to a LOINC code, an ICD-10 code, or some other coding system, like a oncology-specific coding system. But the pros, we wanted to display in our app, we wanted it to be familiar to the end user, so we wanted it to be spelled the same way that it was in the EHR. Especially with order sets. If you're in oncology or any of these specialty areas, these plan definitions or order sets, the spelling of the names are very specific, and practitioners actors in the system, they would like to see when they launch the smart app, like AC followed by T is spelled the same way that they see in their system. And so the way we did this was we used the codable concept text field to kind of localize. And so we asked the EHR developers to emit the spelling of the localized concept in this text field. And then that's what we would display in our app. So we would map using terminology and encodings and match on that. But the display in our app would be responsive based on what the EHR told us in the display text. And we'd fall back to kind of the standard text if it wasn't available. And then we found some disparities in complicated order sets. So in chemotherapy order sets, a lot of times you have multiple cycles, and some EHRs would represent them as different order sets altogether and kind of marry them together in some kind of proprietary way. And so we found using multiple identifiers was a nice pattern where we could have one identifier and maybe all three plan definitions. That meant that this was all AC followed by T with the different cycles or courses. And then a secondary identifier was put on them, so we knew the sequence and we knew like which ones were specifically which course. So we found that caching and testing capabilities, like the other thing is don't hit the capability statement every time your smart app runs. We ran into some problems with that, so don't leave it up to the EHR FHIR server to cache that. You should cache that if you're building an app. And you can cache it and update it even every hour if you want, or once a day. It doesn't have to be a long cache, but caching it is good because if you're testing, you're going to be querying that a lot. Consider a lot of scopes that you ask for at the beginning. I think that's a lot of other speakers have said that. We tried using the HSPC sandbox, which kind of has this multi tenant layer above the happy FHIR server, so you can have multiple different versions of FHIR going if you want to do nice CI across different implementations. We found that coming up with domain modeling might not necessarily literally be the same FHIR resources. Kind of standard API 101, liberally accept, serve what you send. And then for FHIR polyfills, you could do it yourself like we did, but there are other options on the market from kind of CDRs. And I'm not promoting any of these because I don't really, not in the position to, but there are CDR options as well as kind of integration as a service options, and then like Mirth Connect, you can use that too. Yeah, so yeah, if you're interested in Node, we have these open source libraries, a client, a models, and some stuff for React. There's a link, and I think I'm out of time, or I have 2 minutes left, but practically out of time. Oh, yeah. I think these will be available. Someone said they'll send out the things to everyone. Yeah. So thanks. And if there's no questions, applause. Thank you.
All right. It's a pleasure to be here and talk about some FHIR implementation that we've been doing at Intermountain. Just quickly about Intermountain, we're a not-for-profit healthcare provider with 22 hospitals. We've got about a health plan also with 800,000 members, and we've got about 1,500 employed physicians, 35,000 employees overall within Intermountain. This goes back to about 2013 when Intermountain and Cerner came together and created sort of a Intermountain version of the Cerner system called iCentra that we have. And an important part of that was that in the contract that we wrote with Cerner, we stressed the platform nature of what we wanted to try and accomplish. And we both agreed in the contract that we would create an open standards-based API to iCentra and that we would support standards activities for interoperability. And it was a 4-year mission to do that, and there was some money allocated to do that. And coincidentally, concurrently, if you will, FHIR and SMART were coming together. And when we signed the contract, we just said we were going to do standards-based services. But then we quickly, within about 3 or 4 months, determined that we were going to use FHIR and SMART as the ways that we wanted to do it. So we then went to say, well, what are we really going to do? And what we wanted to do is try and take advantage of an application that had already been developed and import that and use it within Intermountain Healthcare. And so we looked, one of the things that we needed was a growth chart application, and we decided that we would import Boston Children's Pediatric Growth Chart. The Growth Chart app, again, was developed at Boston Children's. The target users within Intermountain were people in the ICUs and the pediatric clinics, as well as parents, and to give people, parents, a direct way to look at the growth chart information. So it provides visual display of a patient's growth and development and data against an appropriate cohort. A little more about the app. It's open source. It can be run standalone or integrated with the system, and it uses FHIR resources to access the growth data and the current state in clinical use. So this is something that is in clinical use in the production system today in our ICUs and pediatric clinics. Just a couple of visuals on the growth chart. This just shows, you have the height and weight of the patient, of the baby or infant, and it plots it against known population of babies, same sex, and age, etc. And it has, as you can see, very nice graphics, extremely well done. And it has graphics too that you can show, the parent, you can show the child, and you can show sort of graphically, how the child looks compared to how the parents look. So it's really well done and graphically appealing. The overall sort of technical architecture of this is that we've got the growth chart app. We're talking to FHIR services. Those FHIR services are hosted on top of Cerner's proprietary APIs, and then the data is coming out of the Cerner database, and all of that, of course, is integrated through SMART into the Cerner EMR. So the overall process that we followed, we downloaded the app, I got the source code, we enhanced and modified the application, and I'll talk a little bit more about that in subsequent slides. We followed, the usual testing procedures. We installed the app in a live test environment. We fixed things, then we moved it into the production environment, and we provided the source code back to the SMART team and at Boston Children's. So, similar to some of the things that were talked about in the first talk with Brian, understanding terminology and codes and the representation of the data was an important thing. Now, it turns out in the LOIN codes, you actually have two different things. They're not called this exactly, but they have height, which is how tall you are when you're standing up, and then they have length, which is how tall you are when you're lying down. We didn't think about it too much until we got into it, but the growth charts distinguish that. So they use lengths until the babies can stand, until the infants can stand, and then they start using heights, and it makes a difference in the growth charts. So you actually have to distinguish the lengths from the heights, and that it just takes some getting used to know which LOIN code to use for those things, and then how to match those things up to the same thoughts and concepts within Cerner. You also have all kinds of questions that come up that you don't think about initially, which is you have all of these LOIN codes that also say whether the patient has no clothes, whether they have clothes, and when you're talking about babies, they say whether there's a diaper on or not a diaper on, and you need to make decisions about whether those weights are legitimate for what you want or if you need to do something different with them. Another issue that came up is that the growth charts themselves are based on not just the age of the patient, but the gestational age at birth. So they have different growth charts for babies that are born premature than for babies that are born full term. And in the process, we need to figure that out. And I'll say a little bit more about it on the next slide. But in the normal workflow, you do gestational age testing, so usually ultrasound, and you take measurements of the baby in utero, and then from that you can calculate the expected the gestational age. So you have gestational age at the point of time, but what the normograms want, what the growth charts want, is the gestational age at birth. And it turns out we weren't capturing that, but I'll talk about that in a second. So also, the growth charts, especially in the early immediate days after the birth, it actually matters what time the baby was born. And so you had to be careful that you were collecting both the date and time that the baby was born to have the growth chart work accurately. So coming back to the work integrated with workflow, nobody was entering the gestational age at birth. So you had gestational age at the point in time, and you might have even had multiple gestational ages, and we had to think about, do we want to just use the last one? Do we want to sort of normalize, if there were more than one measurement, normalize that? But there were two ways to tackle this gestational age at birth. One is, you know that a gestational age at a point in time, and then later you're going to have the birth, and so you ought to be able to calculate the gestational age at birth by adding some amount of time, between the birth and between the time that the gestational age was measured and when they were born. We didn't get that sophisticated. What we did is just talk to the clinicians and said, can we add one element? Because they're in there, there is a screen where they enter, the other information about the birth, the gender of the child, the weight, other things. And so we just added a part there to add the gestational age. So, but that was critical in sort of integrating this into the workflow and making it work with the way that people were doing the work. Again, sort of mentioned, and as an ongoing sort of challenge is that FHIR is still new. Versions are changing. Back when we did this, the versions of FHIR that we were working with were version 1. We wanted to use and program against version 2 because version 2 had already been approved, but it wasn't supported yet by Cerner. That wasn't the production version. So, we had this discussion: do we program against the old version and the new version? What do we do? And what we did is basically we programmed our program against version 2, and then we put a widget in the middle that would convert that to version 1 to talk to the Cerner services. And then when we get to a newer version, I think in production we're still on version 1. Version 3 is going to be available, so we'll pull that converter out when we get to a new version. So another thing that happened is looking at knowledge not making the mistake of including changing kind of knowledge in the application itself. So as soon as the clinicians had a chance to look at the growth chart, they said, oh, well, you're showing the World Health Organization growth chart, and I want to see the Center for Disease Control, the CDC version of that. And others said, we want to see the Fenton growth chart. So Fenton is a research group that produces growth charts also. And oh, by the way, you're showing us the 2-year-old growth charts, and we want the current growth charts. So it turns out that they're really a library of growth charts. And in the initial implementation, the growth charts were hard-coded in the application. They were actually in the application code. And so that doesn't lend itself well at all to this kind of changing knowledge base that you want to integrate into the application. So what we did is change. That's one of the things that we changed in the design of the application, is that the growth charts were stored in their own knowledge base along with other kinds of things like order sets and decision logic and other things. But the growth charts were stored as a resource separate from the application, and then you just indicated in the application how often, what growth charts were available that you could choose. So the final thing was printing. You think we took that for granted. The first time that we tried to print, it took like 5 minutes or something to print. And it turned out, when we got to the bottom of it, it was simply just had to do with how the system was configured. But we had to change configuration in the operating system and in the overall network environment to accommodate the printing. It was also challenging to have the print, the screen version appear exactly as the printed version, and to synchronize those two. And so that took us some time to get that working right, but it all worked out. So summary and conclusions. Basically, the growth chart is a beautiful application. It's really well written. The users at Intermountain much preferred the Smart on Fire version of the application as opposed to the Cerner out-of-the-box growth chart. It took longer to implement than we thought, but it was a lot faster than if we had developed the application ourselves and gone through all of the work of creating the application ourselves. We learned a bunch. I already said what we learned. And our subsequent apps have been much faster than the first one. There is kind of a learning curve there, both us learning the FHIR technology, but also just learning the issues and learning what to look for. But in the end, it was absolutely worth it. Really, that we were able to do that, to implement the application, and grateful for, all of the hard work that the guys in Boston put in, which gave us a huge leg up in implementing. So that's all I had. I'm glad for questions, or just go straight to the applause again. But no, yeah. Yeah.